Calc Honors again. All right, so today I'm going to do a little bit of recap of homework 3 and 4, and then I'm going to move on in the packet. I haven't had anybody give me any feedback on these homeworks yet, but I'm going to try and hit the questions that I think, are most asked. Number 6 on homework 3. Again, if yours are different numbers, do not stress. You can pause the video, see if you can find this question anywhere in it, but if you can't, what you need to do is just see if you can follow along with the question I'm looking at and my answer and see if it makes sense. The goal is not to have every single little thing filled in. You're not turning this in. It's, do you understand the question and did the answer make sense to you? Okay? All right. If you can find it and follow along, great. If not, make sure you're still understanding the content. Okay, so I'm on my homework 3, number 6. It says, show that the line passing through these 2 points is parallel to that vector. So I can treat this like a vector. Like, yes, it's talking about a line passing through those 2 points, but I could also treat it like a vector going from here to here. And if I do that, then I would go, okay, let me just get that vector, quotes, in standard form. So 0, 8 minus negative 2, 2. So think of this line as a vector. When I subtract those, I get 2, 6. Now, if you'll remember from lessons before we left or one of my video recaps, I can tell if this is parallel to that based on the fact if it has a scalar multiple. In this case, I would say it does. If I take the number 2 and multiply it through to 2, 6, I end up with 412. So I would say yes, scalar multiple of 2, okay, something like that. Okay, did I have anything else on this one? I did not. Okay. Now I'm on number 9, which is something I talked about in 2 of the videos I did. Write a vector equation for the following, then translate to parametric form. So, vector equation, if you'll recall, xy equals ab plus t, parentheses, v1, v2. The line passing through the point goes in for AB, negative 1, 4. The parallel vector goes in for V1, V2, 1, 6. This is part of my answer. Writing the parametric equations just means separating that. X equals negative 1 plus 1t. Y equals 4 plus 6t. These are the parametric equations. Oops, sorry. Okay. The line, okay, so separate question. So this can be confusing just direction-wise. So this is a totally separate question from part B. We're going to follow the same directions. It says write a vector equation for the line that's passing through these 2 points. Okay? What I don't have here is a parallel vector, so we have to create one. How do I create a parallel vector? Based on what I just did on the last page. I'm going to take the points and subtract them. I could subtract them in either order. It really doesn't matter, because whether I get this vector or this vector, it's still going to be parallel. So I'm taking the points and I'm subtracting them, and that's going to give me my parallel vector. I'm going to call it V. When I subtract them, I get negative 7 minus is negative 5. 5, negative 5. There's my parallel vector. So going back to this, x, y equals, AB has to be a point on the line. They gave me 2 points on the line, so I can pick either one. I'm going to pick 3, -2. The parallel vector we just created by subtracting those 2 points is 5, -5. Now, you could have a correct answer but have used a different point. Okay? You could also have a correct answer. You can't use one of the points here. That doesn't work. But if you had -5, 5, that would also work. Okay? So if we're talking about the line that goes through these 2 points, let me grab scrap paper. Hang on one second. I'm not going to graph them accurately. I'm just going to give you like a general representation. So I want to come up with the vector equation for the line that goes through those 2 points. So what I did by subtracting them was take these 2 points, subtract them, and it does this. I created a parallel vector by subtracting them. That's my 5, -5, not drawn to scale. Okay, so now to write the vector equation, I need a point on the line. I could pick either one of these and put it there. And I need a vector parallel. Depending on what order I subtract them in, I was either going to get this parallel vector or that parallel vector. Doesn't matter as long as it's parallel. Parametric equations, separating x equals 3 plus 5t, y equals -2. I'm going to do minus 5t. There they are. Okay. I can do those again if anybody wants me to. You know, just give me a comment in Google Classrooms. All right, homework 4, the ones I'm going to go over. Number 3. So it wants us to do vector u. I'm going to write them down. 3, 8. In the parentheses, I have vector v. Vector v is 4, 2. Dot product, vector w. So you know, order of operations, we got to do the parentheses first. So the dot product is x times x plus y times y. So when I do x times x plus y times y, I'm going to get -16. I cheated. Looked at my answer key because I can't think of 7,000 things at once. Writing. Where's the camera? What number am I on? What am I saying? My mind is going crazy right now. So I'm cheating. I'm doing the dot product. This times this plus this times this. Multiply the x's, multiply the y's, add them together. Gives me -16. Now, you can't do the dot product with a vector and a number, so this multiplication must just mean scalar multiplication, and we just distribute that through. That's all scalar multiplication is. So the final answer is -48, comma, -128. Okay? All of these, you notice, were just number answers because the result was after a dot product. This guy had a dot product in it, but then we needed to multiply the number to a vector, so that's why that one's still a vector. Okay, show that v and w are orthogonal. Orthogonal means perpendicular. If I find the dot product of v and w, that's going to be -4 times -12 plus 7 times -9. And when I do that, oh, we're showing that they're not orthogonal because I was like, what? When I do that, I get -15. That's me showing that they're not orthogonal. Because if they were orthogonal, the dot product must be 0. Okay? So dot product is not 0. Okay? What else did I have on this one? Now I'm into review. Why is she going to do a review question? Well, because it's a discontinuities one. Find and classify all discontinuities and asymptotes. We've got a rational function. I guess I wasn't clearer on. When I just talk about it in terms of discontinuities and asymptotes, I'm usually referring to vertical asymptotes, but I can do a little horizontal asymptotes here as well, just in case anybody thought that I wanted that as well. Okay, so I'm factoring the top, I'm factoring the bottom. Boop, boop, factoring. This is going to give me 3x minus 10. This is going to give me 2x plus 1. This is going to give me x equals 10 thirds. This is going to give me x equals negative 1/2. Now, oh, I'm sorry. I'm going to get good at this. I'm going to get good at these videos. These are both discontinuities, but I can't classify them until I look at the top. When I look at the top, it can be factored. However, that factor doesn't match either of the ones on the bottom. So these cannot be removed, which means that I have two discontinuities and they are both essential. I have no removable discontinuities here. If I happen to have like an x here and an x equals 0, I would say, okay, x equals 0 is removable. Not the case. Okay, these are also both vertical asymptotes. All right, let's talk horizontal asymptotes. Horizontal asymptotes. None of this work applies. None of this applies for horizontal asymptotes. It's a totally different thing. Horizontal asymptotes, you take the leading terms. This is what I would consider, what everybody would consider, same degree. This is not bottom heavy. It has nothing to do with the coefficients. When I reduce this, the x's go away completely, leaving me with a constant. Okay, the coefficients. That is where my horizontal asymptote would be. If it looked like this, I would say there's no horizontal asymptote. That's top heavy. When it's top heavy, it's going to go up like that, down like that, one or the other, in both directions. That's my kid coughing. Okay. If it was bottom heavy, so now let me do x squared over 6x cubed. Bottom heavy, I would have a horizontal asymptote at 0 because that means it's going to the x-axis. Bottom heavy, it's going to the x-axis in both directions. Top heavy, that guy's going to go up, down, both directions. No vertical asymptote. No horizontal asymptotes. Same degree, it's going to have a horizontal asymptote, it's just not going to be at 0. It's going to be wherever your coefficients are. Okay, this video is getting too long, so this is my going over homework 3 and 4 video, and I'm going to start another one to start the next page of notes.